Hey guys, my name is William Salisbury and I'm here with Drafting Book Design. Today we're going to go over a just-in-time principle. A just-in-time is just to give you the gist, so you can have all the information you need on a single concept. Today we're going over polylines. What are they? What makes them different? What makes them useful? So the first thing we need to do is build up a construct so you understand what a polyline is. So let's start off with its predecessor. Here is a regular line. The first and probably one of the most essential elements of AutoCAD is the line. Knowing the difference between a line and a polyline is very important because a polyline can save you a lot of time and a lot of effort. So here, as you can see in our properties, we'll go ahead and lock that out there so we can keep that up. We're looking at a line right now. It's got all the basic characteristics: color, line type, line scale, so forth on. A polyline has those same general properties, but you've also got some unique qualities under geometry and miscellaneous. So at first they may look identical, but there's a characteristic of polylines that comes in the form of global width. Global width allows you to specify a thickness. Lines themselves can also be given thickness, but that's normally done by modifying the pin table. So the pin table will associate a line thickness, or you can define that quality up here. So over here. So now I'm saying this particular line will, when it's printed, it's going to have a 0.40 millimeter line thickness. Now that'll be overridden by the pin table. For those of you not familiar with what a pin table is, when you go to print, these are pin tables. Those of you that might not be familiar with what a pin table is, these are the pin tables. These are CTBs. There's actual multiple options. There's a style-based and a color-based. The CTB is a color-based. That means the color that you make that line, whether you make it that line itself or the layer that it's on a certain color, then this is going to make, I'll show you, those colors come out at a certain thickness. Right here you'll see line weight. So here you'll associate 0.5 millimeter line thickness with the color red. And you can also reassociate colors too. So if you want all your red stuff to come in red, damn, right there. Right now it's all set to black because we're in a monochrome pin setup. So the goal is to make every color turn to black. This is particularly useful, but we'll cover that in a different lesson. Right now, you just need to know that when you have a pin table that will affect the thickness of a line, it will not affect the thickness of a polyline. The main reason why is what a polyline is. When you switch over to a hidden perspective, you can see that the polyline is like a polygon, but it doesn't have the editable corners. So what this basically is just a rectangular polygon that you cannot edit. Okay, so we're back to this. So now that we understand that a polygon, when you bring it down or explode it, is basically just a line, we can understand the association there. Now why would you pick this besides just the width factor? Why not just use lines? Well, a polyline can be kept in a running series, which means you can keep on going and those lines stay connected to one another. You can also draw another polyline that connects at the endpoints. These are two independent. But you can use the join command to connect those polylines together. And that's going to be important as we'll go over in a later section. Okay. Also, to get to polylines, if you already have existing line work, see, these are all individual lines as you can see in the properties palette. Okay, so we have a lot of lines. There is the PE DIT. What is that? Is P-edit. And you can hit multiple, which is what you want in this case because we have more than one line. And we're going to convert all of those to polylines. Okay, and that's done. These are all now polylines, as you can see in the properties palette. The p-edit command also has multiple options besides just turning lines into polylines. You can also join the polylines after you've selected them. Enter the fuzz distance. I'm going to say accept the default of 0, 0, 0. Okay, and now all those lines have become polylines. All those polylines are now joined together. Okay. Polylines are also useful and speed up a process because unlike regular line work, say if I wanted to fillet this line, and I know that I want a, let's say, 1/2 inch. That's a little bit small for what we're doing. Let's go and say 4 inches. Yeah. Okay. So I'm gonna move these based on their quadrants. So I know I want the arc to look like that. So I say fillet, and I want to fillet my polyline, and I'm going to pick a radius for that fillet, and I want it to be there. That's the radius of the circle, so that's the radius I want. Now the thing is, since I've hit polyline, as you can see when I hover over the line, it's going to make every bend in that polyline fillet to that radius. So it kind of helps you if you have a common radius between a long segment. Okay, saves a little bit of time on that. Also, polylines have another feature that puts it quite a bit in its own class away from line work. Okay, when you start drawing a polyline, it is continuous until you end. If you end with a C command, which is to close it, it becomes a closed polygon. So if I just go erratic, turn off my everything, and I hit C, this is now a closed, well, not necessarily a closed polygon because this one has overlapping features, but it becomes a closed system. So if I move this, you can see it's still connected to its endpoints. Okay. One more feature. This will be our last thing that we cover. Is that when you have a unique footprint, and this is going into something a little bit further down the line for most people, I am now in a 3D perspective. So I've changed to my isometric perspective, which means I now have a z-axis, so I have an elevation besides just my north and easting. There is a command called extrude, which works with closed polygons. Which allows you to make 3D objects. I'll just switch over to my conceptual view. As you can see, we've created 3D objects from a 2D footprint. Now, to do that, you either have to have a polygon or a polyline that's enclosed. So, that's another feature. If there's anything else y'all would like to know about polygons or would suggest that would be put into this basic tutorial, go ahead and leave a comment. And we hope you all have yourselves a wonderful day.